1.4 billion kilometers from the Sun, buried inside the rings of Saturn, there is a moon that has no business being alive. It is tiny, barely 500 kilometers across, smaller than the state of Arizona, its surface locked at minus 200 degrees Celsius, a frozen leftover from the birth of the solar system, circling a gas giant in the outer darkness, doing absolutely nothing for 4 billion years. That is what scientists expected when they pointed instruments at it. What they found instead has now become the single most important target in the entire history of astrobiology. And in January 2026, a team of researchers in Japan and Germany did something that stopped the scientific community cold. They rebuilt the ocean inside this moon on a laboratory bench, and it worked. The first sign that something was wrong with the dead moon theory came in 2005, when NASA's Cassini spacecraft made its third flyby of Enceladus and detected something the instruments were not designed to find. Saturn carries one of the most powerful magnetic fields in the solar system. That field should sweep past a small frozen rock the way wind moves past a stone. Instead, it was bending, curving, wrapping itself around Enceladus as though it had collided with something soft and expanding. Magnetic fields do not bend around ice. They bend around gas. Something was streaming off this moon in enough volume to physically push back against the magnetic field of a planet 95 times the mass of Earth. Controllers rewrote the flight plan immediately. Cassini was redirected back, lower, faster, every instrument aimed at the southern hemisphere. What it found was not a dead rock. Enceladus was erupting. Like and subscribe. Because what Cassini found coming out of that moon is the reason the European Space Agency just made the biggest funding commitment in its 50-year history. Near the South Pole, Cassini's cameras resolved 4 enormous fractures gouged into the surface crust, each one running more than 100 kilometers long, dropping hundreds of meters deep. Scientists nicknamed them the Tiger Stripes. Formally, they carry the names of desert cities: Alexandria, Cairo, Baghdad, Damascus. Out of those canyons, Enceladus was firing towering columns of water vapor, ice grains, salt, and organic gas into the vacuum at speeds approaching 100 kilometers per hour. The eruption was so powerful that most of the material never fell back to the surface. It escaped entirely, spread along the moon's orbital path, and formed a vast ring around Saturn called the E-ring. Enceladus was not just orbiting Saturn, it was paving its own orbit with frozen seawater, and that single fact carried an implication that changed everything. You cannot spray liquid water into space unless you have liquid water to spray. Beneath that frozen crust, something had never frozen. Gravity and density measurements mapped what was underneath. Below roughly 20 kilometers of ice, far thinner near the South Pole, Enceladus holds a global liquid ocean of salty water approximately 10 kilometers deep, deeper than the Mariana Trench. In a place where sunlight reaches at 1% of its Earth intensity and cannot melt anything. So the obvious question became the most important one in planetary science. What is keeping that ocean liquid in the coldest part of the solar system? The answer is gravity applied as violence. Enceladus is locked in a gravitational rhythm with a larger neighboring moon called Dione. For every single orbit Dione completes around Saturn, Enceladus completes exactly 2. Every time they align, Dione pulls. That pull prevents Enceladus from settling into a stable circular orbit. Instead, its path is stretched into an ellipse permanently. So the moon is constantly falling towards Saturn and then drifting away, falling and drifting in an endless cycle. When it swings close, Saturn's gravity physically deforms the entire body. When it drifts out, the moon relaxes. Squeeze, release, squeeze, release, for billions of years. Deep inside the rocky core, that constant flexing grinds rock against rock. Friction generates heat. Scientists call it tidal heating, a permanent internal furnace powered by nothing more than the gravitational relationship between 3 objects, melting the base of the ice sheet from below and keeping an entire ocean liquid in the dark. Like and subscribe, because an ocean is only the beginning. What Cassini found dissolved inside that ocean is the part that changes the conversation about life in the universe permanently. For years, the chemical evidence came from ice grains sampled in the E-ring as Cassini flew through. Those readings returned. Organic compounds. In 2018, something more significant appeared. Large, complex, carbon-bearing macromolecules. But a problem remained that no researcher could fully dismiss. Grains drifting in the E-ring can be months or centuries old, sitting in a punishing radiation environment the entire time. Radiation can manufacture complex molecules in space that have nothing to do with what is happening inside the moon. So researchers went back to the fastest, closest plume crossing Cassini ever made. The 2008 pass, where the spacecraft flew through the geyser at just 21 kilometers above the surface, moving at 64,000 kilometers per hour. The ice grains collected on that pass had left the ocean minutes earlier. Radiation damage at that age is effectively impossible. The reanalysis of those samples was published in the autumn of 2025. Inside those fresh grains, researchers identified aliphatic chains, cyclic esters and alkenes, ethers, and signatures of nitrogen and oxygen-bearing compounds, molecules never previously detected in ice from any ocean beyond Earth. Esters and ethers are chemical connectors, the molecular joints that allow simple carbon structures to assemble into complicated ones. The ambiguity was gone. This chemistry was not manufactured in space. It was manufactured inside Enceladus. To understand what could be making molecules like that under 20 kilometers of ice, researchers looked at the only comparable environment they knew. Kilometers beneath the Atlantic Ocean, in permanent darkness, Earth's crust splits open. Superheated, mineral-rich fluid pours out of towering rock chimneys and collides with near-freezing seawater. That collision triggers a reaction called serpentinization. Iron and magnesium-rich rock reacts with water, releasing warmth, hydrogen gas, and exactly the type of complex carbon molecules Cassini pulled from the plumes of Enceladus. Around those vents on Earth, life does not merely survive. It crowds in. Tube worms, bacterial mats, entire ecosystems that have never seen sunlight and do not need it, because they run on chemistry instead of light. Cassini detected molecular hydrogen streaming out of Enceladus. On the seafloor of Earth, hydrogen is not a background chemical. It is food. It is the foundation of a food chain. Like and subscribe. Because what happened in January 2026 is the most significant development in this story yet. Astrobiologists evaluate a potential habitat using a checklist of 6 elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, collectively known as CHNOPS. Those 6 elements compose essentially every living organism ever examined on Earth. Cassini found the first 4 in Enceladus without significant difficulty. Phosphorus was missing. That absence was not a minor technical gap. Phosphorus forms the structural backbone of the DNA double helix. It sits at the center of ATP, the molecule every living cell on Earth uses to transfer energy. Without phosphorus, you can have interest in chemistry. You cannot have biology. The answer arrived in 2023, 6 years after Cassini was deliberately deorbited into Saturn. Researchers returning to archived E ring dust measurements found unmistakable signatures of dissolved phosphates at concentrations hundreds of times higher than anything in Earth's seawater. Every element on the checklist was now accounted for. Not inferred, not modeled, but directly measured in material that came from inside the moon. Having the ingredients is not the same as being able to cook. So in January 2026, teams in Japan and Germany rebuilt the ocean of Enceladus on a laboratory bench. They replicated the pressures, the temperatures, the mineral chemistry, and the hydrothermal reactions. Then they ran the experiment. The reactions produced a wide range of complex organic molecules: aldehydes, nitriles, and amino acids. The freezing process itself generated simple amino acids, including glycine. Many of the products matched what Cassini had measured at Saturn almost exactly. A recipe written on another world, reproduced in a laboratory on this one, and it works. Amino acids are the building blocks of proteins. Proteins are the building blocks of cells. Enceladus is not a place where life might one day be possible under the right conditions. It is a place where the chemistry that precedes life has now been demonstrated to operate on its own in conditions we can measure, replicate, and verify. And the moon is still active. Right now, while you are reading this, in 2022, the James Webb Space Telescope observed the south pole of Enceladus and detected a single continuous plume of water vapor extending more than 9,600 kilometers into space, nearly 20 times the diameter of the moon itself. Webb measured the output at approximately 300 liters of water per second, escaping continuously into the Saturn system. The internal furnace that keeps that ocean liquid is not a geological memory. It is burning at this moment, which makes the obvious question unavoidable. If the ocean is warm, salty, chemically complete, actively producing organic molecules and continuously venting material into space, why did Cassini not find the organisms? The answer has nothing to do with biology. Cassini was designed in the 1980s and launched in 1997. Before anyone knew Enceladus had an ocean or a plume, it was built to survey an entire planetary system, to weigh molecules, chart magnetic fields, and map terrain. It carried no microscope. It carried no instrument capable of detecting a cell wall or sequencing genetic material. Cassini did not fail to find life. We never gave it the instruments to look. It found smoke pouring from every crack in the ice and had no way to follow the smoke to the source. That is what ESA's L4 mission is designed to fix. By mid-2026, the Instrument Development Working Group was finalizing the payload concept and technology roadmap. Mission adoption is expected around 2034. Launch is planned for 2042. Arrival at the Saturn system is targeted for the early 2050s. The spacecraft is not a flyby. It is an orbiter carrying a lander, designed to descend directly onto the erupting south polar terrain of Enceladus, collect samples from the surface itself, rather than from orbital plume crossings, and operate in place for weeks. The payload being designed for L4 includes a mass spectrometer, descent and surface cameras, geophysical instruments, a dedicated sampling system, and a biomarker detection laboratory specifically built to recognize the signatures of life. Unlike Cassini, this mission is being designed for one question and one question only. The mission lead confirmed publicly that the L4 mission will definitely happen, and will very likely go to Enceladus, a global ocean, a permanent heat source, a rocky seafloor producing hydrogen and complex organics, a laboratory experiment proving the chemistry assembles itself, and now a machine being built to go look. For the first time in human history, the question is not whether we could search for life beyond Earth. The countdown has started.